Okay, now we look at BMQ 2C. Okay, before this we recap that, remember we learned before in our lecture question. Let's say for example, if we are looking at the argument of Z1, Z2, right? This is the same as the argument of Z1 plus the argument of Z2. Okay, and if we are talking about the modulus of Z1, Z2, this is the same as the mod of Z1 multiplied with the mod of Z2. Okay, so why is this true? Because let's say we think about it, let's say Z1, right, is let's say you just use the exponential form. Actually it's very clear. Okay, mod 1 R1 e theta. Let's say Z2 has the modulus R2 and the argument I theta 2. If we were to multiply both of them together, you can see it's just R1 R2, and this is E using the addition law, the product law, right? Theta 1 plus theta 2. So you can see that this is like the argument of Z1, Z2, right? And you can see that this is like the modulus of Z1, Z2, correct? So quickly from here, okay, let's go proceed on to solve 2C. So 2C is very easy. What we do is you can consider this as Z1. You can consider this as Z2. And then we go on to solve the question. Okay? Okay, so next, how to do? Okay, let's look at Z1. So maybe -1, the argument. What is the argument of -1 minus I? Okay? So solving this by side, I'm sure you're able to get. So -1 minus I, if you use the real imaginary, you can see that -1 minus I somewhere here, right? This is a -1, -1, right? Oh, sorry, wrong. Okay, so -1 somewhere here, -1, -1. So don't go and put -I, it's -1, so it's just here. Okay, okay, and from here, where would be the argument be? It will actually be this lah. It was taken from the positive real axis, right? So remember, we go on to find our triangle. We realize that this is just a pi over 4, and green portion here, this will just be -pi plus pi over 4, right? So it's our argument is -3 pi over 4. Okay, and so our argument of -1 minus 2i minus I is -3 pi over 4. Okay, very quickly you can say that the modulus of -1 minus I would also be square root of -1 square plus -1 square, right? Because we only take, remember, we don't take -I square, we're taking the imaginary part which is real. So the imaginary part of this -I is -1, right? So it's equals to square root 1 plus 1 is actually square root 2. It's square root 2. Okay. Alright, how about the other side? Let's look at Z2. Alright, the argument of -1 plus square root 3i. Okay, so very quickly, we need to just draw it out on the Argand diagram. -1 square root 3i. Okay, -1 square root 3. Okay, and then from here like that. Okay, and this would be your basic angle. So you just take pi minus tangent inverse. Okay, and you should be able to get that the argument here should be equals to 2 pi over 3. Right? Very quickly, the modulus. What about the modulus of -1 plus square root 3i? Okay, this would be -1 square plus square root 3 square, so it's like square of square root 3. So it's like 1 plus 3, so actually you get square root 4, so it's 2. Alright, so combining this and this, combining this and this, right? Remember the argument overall, -1 minus I, -1 plus square root 3i, right? This will just be, remember, it's supposed to be 2 times square root 2, right? 2 times square root, because remember 2 square root 2, they came from here, right? And we add the arguments, so we multiply the modulus and we add the argument. negative 3 pi over 4, 2 pi over 3. So it's e to be the power of I, negative 3 pi over 4 plus 2 pi over 3. Okay, and with that we get 2 square root 2 e to the power negative I pi over 3, and we check that I pi over 3, pi over 12 is still within the principal range, so there's no need to do any switching to make it into the principal, the plus 2 pi minus 2 pi. Okay, and this is actually already in the exponential form. We want to convert to the polar form, right? This is r, remember this is r, this modulus, this theta. So very quickly, the polar form will be 2 square root 2 r cosine negative pi over 12, right? This is the theta, plus I sine negative pi over 12 as well. Okay, so we are writing, remember that our polar form is r cos theta plus I sine theta, right? And we are writing our template, so remember that it must be a plus and it has to be a modulus. Okay, we cannot write it in another form.